Hello, ladies and gentlemen. Welcome to another very exciting day of Living Environment. I am your teacher, Ms. Parsons, and we're going to be looking at Unit 1, Day 2 of Scientific Inquiry. So let's go ahead and get started. Our aim today is what is the importance of the scientific method? And the scientific method is probably a term that you are familiar with. You can see it down here below. So this idea of a process, kind of like you would conduct in an experiment for a science fair when you're in elementary school, right? So you start with the question, something that you're curious about, and you go down to the hypothesis. So you say, I wonder if plants could grow with Diet Coke instead of water. So that is your question, what helps plants grow? Water, we know, but we have this hypothesis. I hypothesize that plants could grow in Diet Coke instead of water because Diet Coke has enough water in it. That could be your hypothesis. How would you test the hypothesis? Well, you would set up some plants and try to grow them for your experiment with Diet Coke or with water. And then you would see, once you get your data, did plants grow with Diet Coke? Did plants grow with water? You might have different methods of gathering your observations, such as measuring the height of the plant or taking daily photos. But in the end, you are going and analyzing the data from that one experiment and putting it in a report. And that is true, and that is the scientific method. However, we want to broaden our horizons with the idea that scientific inquiry is a process that involves taking this question, having your hypothesis, and going, once you conduct your experiment, going back, you modify your hypothesis, you go and see your data, you go back, you experiment again, and then you analyze your data. And this is the process that scientists actually use when they are conducting real experiments, right? So they may start with their question, their topic of interest, but they wind up going back several times and experimenting in different ways in order to find solutions and gather meaningful data. So, all of this to say, the process of science is just that, a process. It is a method of learning, of studying our world, and finding out information about our planet. So, now let's go ahead and look at the do now. So, read and respond to the text below. There have been a number of studies that have emerged since the start of the pandemic, looking at the increased risks of patients with various comorbidities, not limited to cancer. So since the COVID-19 pandemic, they're looking at increased risks of patients with various comorbidities. You may have seen this word in the news a lot. That word means various illnesses occurring at the same time, right? So if someone has diabetes and hypertension, and then they get infected with COVID-19, those are their comorbidities, the illnesses that they already had. We've heard talk about diabetes and hypertension. So what we do know is that cancer puts patients at an added risk for the worst outcome, meaning death, with lung cancer in particular, because we know COVID-19 affects your lungs, in particular of the various malignancies seems to be. So what is this passage actually saying to us? It's saying that there have been a number of studies, right? And you may have seen this idea of a number of studies before on like a TikTok conspiracy theory, studies say. But in this case, when we're talking about science and we're talking about scientists that are compiling this data, this looks like, the source is Amy Moore, PhD. Can we trust what she says? Well, if we have her level of expertise, in biology, maybe we're epidemiologists, we can go in and we can analyze the data ourselves. But in general, what we use in science to accept what scientists say is a process called peer review. And what reasons do you have to believe this peer review process? Well, we have data, and we also have consensus. So you may have heard, debate about climate change, right? And forgive me, the things that I'm writing are atrocious to read. But so the process of peer review is what happens after scientists have gone, they've taken their question, their hypothesis, they've experimented, they've gone back several times. This is like a second analysis process. Another scientist that has their same level of expertise, so you wouldn't have a chemist reviewing a biologist's work unless they were looking at the chemistry aspects, but a group of their peers, right? And very technically, they're biologists, they're scientist peers, go and review the data and look at the experiment. And then once many scientists in the same expertise review data and conclude that they all agree the data is sound, it was gathered using appropriate scientific methods, then we have this idea called scientific consensus. So for example, again, I talked about climate change. You may have heard debate about climate change, but overwhelmingly, the majority of scientists, the majority of ecologists agree. They have this thing called consensus that climate change is severely impacting the world around us. So, is it okay to just accept what scientists say? No, you don't just accept it, right? Because scientists are just like any other people. They could be, presenting data that wasn't gathered correctly. They could have made a mistake. So what reasons do you have to believe them? Well, you can look at their data and you can analyze it yourself. And you can also look at the analysis of others, peer review, and scientific consensus. So if many people agree, it's probably a good sign that it's true. So now let's look at our vocab of the day. So some terms that may or may not be new to you. Let's see. So what is a testable idea or explanation that can be assessed through further investigation and experimentation? That is a hypothesis. How about the variable being tested and measured in an experiment? So thinking back to the experiment that I talked about just above, where we were talking about Diet Coke and water to grow plants, in that case, the variable being tested and measured is if the plants grew. That is the dependent variable, right? So that is the variable that's being measured. That is the one that's being affected. And we also have the variable that is changed or controlled in the case of Diet Coke and water to grow plants. That independent variable was what we use to water the plants, right? So the Diet Coke or water, and that is what it is being changed or controlled by the experimenter, right? So that's the cause. So your IV is the cause and your DV is the effect. So in the case of the experiment from yesterday, from day one, where I talked about my students that conducted an experiment where they tested different concentrations of bleach on hair extensions to see the different color range that the hair extensions would change. So in their case, their independent variable was the concentration of bleach that they used on the different hair extensions. And you may recall that I told you that students used 3 different concentrations of bleach to determine if the hair would get lighter and lighter. That was their hypothesis. As it turned out, you may recall, their experiment didn't work out so perfectly, and they didn't wind up showing any difference between the 3 concentrations of bleach, and that was their dependent variable. The dependent variable was the effect on the hair, and the independent variable was the different concentrations of bleach. If you guys commented below on the last video, you may have already written that down. But you can check your work now. So we're talking about independent variable and dependent variable. And again, independent variable is the cause. It's what's being changed by the experimenter. And the dependent variable is the effect. So now, the group in an experiment that receives the variable being tested, that is the experimental group. And then there is a group in an experiment that does not receive the variable being tested, thinking back to the Diet Coke and water experiment, right? Water is what you normally grow plants with, so you would refer to that group as your control group. And in the case of my girls with the different the results. So why is this important? Well, these terms here will be used throughout our year in living environment to describe many different scientific experiments, and you will be designing and planning your own scientific experiments, especially if we were able to work here together in lab, but even from home, you will be utilizing this terminology, and it's especially critical that you understand the difference between independent and dependent variables. So if you have any questions about that, please feel free to drop them in the comments below and respond to your peers, and you can also ask them in the Zoom call tomorrow. So let's go on to the second page, and we're going to clear all drawings. Does that work? Ah, yes, perfect. Okay, so now, the electronic cigarette, an item that can satisfy a smoker's nicotine craving without burning tobacco, has been on the market for over 3 years now. This device has not yet been linked to cardiac disease, cancer, or chronic respiratory disorders, which are commonly related to smoking tobacco cigarettes. An e-cigarette consists of a rechargeable battery as well as a small cartridge, which contains liquid nicotine. The battery is used to heat the cartridge, which in turn allows the liquid nicotine to turn into water vapor. So we have here, we're talking about smokers and their nicotine craving, right? So nicotine is what makes cigarettes addictive. And we have this new device called an electronic cigarette that has been on the market. You guys have probably heard of different brands of electronic cigarettes. And it has not yet being the key phrase, right? Just like we have data about COVID-19, but we don't have a lot of firm conclusions yet because it is such a new illness. 19, it just started last year. It has not yet been linked to cardiac disease, cancer, or chronic respiratory disorders, even though research may conclude that it is linked to those things later. But we do know already that cardiac disease, especially lung cancer and chronic respiratory disorders like COPD and emphysema, are related to smoking tobacco, smoking cigarettes. So, though markers of the e-cigarette often herald their product as a much healthier alternative, local researchers are interested in determining whether this new fad is actually a fast track to becoming strongly addicted to nicotine. So their hypothesis is that although people are saying these e-cigarettes are healthier, actually it's going to make you more addicted to nicotine. And why do they say that? They have designed an experiment including 10,000 cigarette smokers, 5,000 of which were asked to switch over to e-cigarettes. The researchers plan to monitor how many cigarettes the people in each group smoke per day. The data from this experiment will allow the researchers to conclude whether the e-cigarette causes an increase in smoking, indicating a greater extent of addiction. So, what are the local researchers testing? They are testing if e-cig causes increased smoking. What are they manipulating? They're manipulating the method of nicotine consumption. Right? So they're manipulating, they're saying either e-cigarette or real cigarette. Those are the two different conditions in this experiment. What are they measuring? They're measuring the number of cigarettes smoked, or in the case of e-cig users, the number of cartridges burned. So I would guess that in this actual experiment, although it doesn't tell us here, the data would be in milligrams or micromilligrams of nicotine consumed per day. So what is their hypothesis? Their hypothesis that they are testing is if they predict that the e-cigarette will cause an increase in smoking. So does the e-cigarette cause an increase in smoking because it's a more efficient method of nicotine delivery? So the hypothesis is that e-cig will increase smoking. The independent variable is the method of nicotine consumption. So is e-cig versus cigarette. And the dependent variable is the amount of nicotine consumed. Or I guess cigarettes smoked is how they defined it. And why did the experiment include 5,000 smokers who were not using the e-cigarette? That takes us back to the vocabulary terms that we went over. They are the control group. So they are showing sort of typical smoker cigarette use, typical amount of smoking, and they're comparing those 5,000 smokers to the 5,000 smokers who have been switched over to the e-cigarette. What is interesting about this passage from a scientific literacy perspective is you can see here the first part of this passage is all talking about the health of the e-cig versus the health of the cigarette, but then it goes on to talk about nicotine consumption and levels of nicotine consumption. Frequently, when you read about science in the media, the people that are writing about the science, the journalists, are not scientists themselves. So it is difficult for them to understand an experimental trial when they read a blurb about it. And this is part of why in Living Environment, we find it so important to learn about the different methods of scientists and the scientific inquiry process. That way, when we have to draw conclusions about science data based on information that we may see in the news and in the media, we understand what we're looking at, right? We have the minds of scientists. So go ahead now, once you've finished your notes and answered these questions, and complete the Unit 1 Day 2 exit ticket, which should be shared on your classroom stream. I hope this video was helpful to you guys and not too confusing, but if it was confusing, please feel free to come to class on Tuesday onto the Zoom call with your questions. Please don't forget to like and subscribe to my channel and go ahead and hit that little bell for notifications. Comment below, increase my engagement. All of your teachers are YouTubers now. What fun. See you all on Zoom and have a great day. Bye.